Good day, this is the Professor, CBMD PhD. And today's Friday, June 16th, 2023. It is 6:48 and 35 seconds, AM Eastern Daylight Time. And today's research, structured light. So let's hop to it here. Researchers demonstrate noise-free communication with structured light, a new approach to optical communication that can be deployed with conventional technology. Date June 9, 2023. Source, University of Witwatersrand. The patterns of light hold tremendous promise for a large encoding, alpha and optical communications, but progress is hindered by their susceptibility to distortion, such as atmospheric turbulence or in-bed optical fiber. Researchers have outlined a new optical communication protocol that exploits spatial patterns of light for multidimensional encoding in a manner that does not require the patterns to be recognized, thus overcoming the prior limitations of model distortion and noisy channels. The result is a new encoding state-of-the-art of over 50 vectorial patterns of light sent virtually noise-free across a turbulent atmosphere, opening a new approach to high bit rate optical communication. Researchers used a new invariant property of vectorial light to encode information. This quantity, which the team called vectorness, scales from 0 to 1 and remains unchanged when passing through a noisy channel. Unlike traditional amplitude modulation, which is 0 or 1, only a two-letter alphabet, the team used the invariance to partition the 0 to 1 vectorness range into more than 50 parts, 0.0.02, 0.04, and so on, up to 1, for a 50-letter alphabet. And because the channel over which the information is sent does not distort the vectorness, both sender and receive will always agree on the value, hence noise-free information transfer. The critical hurdle that the team overcame is to use patterns of light in a manner that does not require them to be recognized, so that the natural distortion of noisy channels can be ignored. Instead, the invariant quantity just adds up light and specialized measurements, revealing a quantity that doesn't see the distortion at all. And this is a very exciting advance, because we can finally exploit the many patterns of light as an encoding alphabet without worrying about how noisy the channel is. In fact, the only limit to how big the alphabet can be is how good the detectors are, and not at all influenced by the noise of the channel. And to create a detective vectorness modulation requires nothing more than conventional communications technology, allowing the model patterns-based protocol to be deployed immediately at real-world settings. The team have already started demonstrations in optical fiber and in fast links across free space, and believe that the approach can work in other noisy channels, including underwater. And this is the Professor on Advanced Physics, Mathematics, Computer Science, and Leader of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.